Follow two questions. We want to see if it's true. If not, give a counterexample. So the first one says if f of x has a local minimum value at x equals c, then f prime of c is equal to 0. Well, this is not true, because let's consider f of x equals x to the 2/3 power. If we take the derivative, that's going to be 2/3 x to negative 1/3 power. And now if you set this equal to 0, it's never going to equal 0. Okay, but it's undefined at x equals 0. Okay, so when we're doing the number line, the first derivative number line, you want to put in the critical numbers. Okay, so for the critical numbers, there's two criteria. Either f prime of c equals 0, or f prime of c is undefined. Okay. It's one or the other. Okay. So in this case, it's going to be undefined at x equals 0, and if we plug in a point to the left of 0, let's say negative 1, into the derivative, this will be negative 2/3, which is negative. And if we plug in a number to the right of 0, let's say 1, that's going to be positive 2/3. So that's positive. The derivative is negative, which means f is decreasing and then increasing. So we have a local minimum at x equals 0, but f prime of 0 does not equal 0. So this is false, this statement right here. Now the next statement, we have f and g are both differentiable. Then the derivative of f times g of x is equal to the derivative of f times the derivative of g. Well, this is a product. Whenever you take the derivative of a product, we have to use a product rule, which says it's the derivative of f times g of x plus the derivative of g of x times f of x. That's not the case here. So we know automatically it's going to be false. So let's look at a counterexample. So for the counterexample, we're going to let f of x equal x, g of x equal e to the x. If I take the derivative of x times e to the x, that's just going to be e to the x plus x times e to the x. But using this method, it would say derivative of f is 1 times the derivative of g, which is e to the x. So you would get e to the x using this method. Clearly, these two are not the same. You're missing an x times e to the x term. So therefore, the statement is false.